Okay, let's get into this. We are tackling a concept so fundamental, it's basically behind everything. Why the lights are on, why stars burn, why we even exist. Today's deep dive is all about energy.
Right.
And what our sources make really clear right from the start is that energy is what makes everything happen. It's what makes things move, change, exist, even the stuff we can't see.
Hmm.
I mean, you look around and you think things are still, but nothing really is. Motion, heat, light, sound. It all comes from energy flowing from one place to another.
And that brings us to the simplest physics definition we have.
Mm.
Energy is the ability to cause change. That's it.
Simple as that.
It's not just some fuel. It's woven into the very fabric of the universe.
A great example of this, the one that always clicks for me, is holding a rock. You hold it up, and it's not moving, right? It just looks still.
Yep.
But it has stored energy, potential energy, and that proves energy can be there even when it seems like nothing is going on.
Exactly. Then you drop it, and that stored energy instantly becomes the energy of motion. That distinction is so important.
Okay, but this is where my brain starts to hurt a little. What about the particles themselves? Are things like electrons or protons? Are they just pure energy?
That's a great question.
Yeah.
And the strict answer is no. They're particles, but they're defined entirely by the energy they carry. They're expressions of energy.
Which I assume brings us straight to Einstein.
It has to. You can't talk about this without E equals mc squared.
Yeah.
It's the moment where matter and energy just home. They stop being two different things.
So what does it really mean?
It means mass itself is just an incredibly condensed and incredibly packed form of energy. Matter isn't separate from energy. It is energy.
Wait, so this desk, the air, everything, it's all just energy that's been packed so tightly it feels solid to us?
That's the mind-bending truth of it, yeah.
Mm.
And the energy can express itself in motion, which we call kinetic energy, or as heat, which is just the vibration of atoms.
Okay, but what if you could stop all that vibration? Cool it down to the coldest possible temperature, to absolute zero. Does everything finally stop then?
You'd think so, but no. Even then, particles are still not completely motionless. There's this tiny leftover quantum hum. We call it zero-point energy.
So perfect stillness. It doesn't exist.
It literally doesn't. There's always a baseline of movement.
So if matter is condensed energy and it's always moving, what's going on in the empty space between all the matter?
Ah, that's where fields come in. A charged particle, like an electron, creates an electric field all around it. And that field, that is energy stored in space itself.
Not in the particle, but in the space.
In the space. When two particles attract or repel, they aren't actually touching. The interaction happens through the energy in that field. Energy is everywhere.
And on the quantum level, how does that work? How is energy defined by, what is it, frequency?
Exactly. This is the other huge equation. E equals h times F. It just means energy is directly tied to frequency, how fast something is vibrating.
Higher frequency, higher energy.
Always. Think about light. It has no mass, no charge, but it carries energy because it has a frequency. Red light has a low frequency, low energy.
But then you get to something like gamma rays.
And their frequency is astronomical, and so is their energy. They're both light, just vibrating at wildly different speeds.
This all leads to a pretty radical view of reality, doesn't it?
It does. The modern view, quantum field theory, says particles aren't little balls at all. They're just localized vibrations, excitations in their specific fields. An electron is just a ripple in the electron field.
A ripple. Wow, so that means even so-called empty space isn't empty?
Not even close. The vacuum is humming with what we call vacuum energy. It's constantly fluctuating, creating and destroying tiny virtual particles for brief moments. The universe is saturated with energy.
So in the end, it all just changes shape.
That's the final piece. The law of conservation of energy. It says you can't create or destroy energy ever. It only changes form. Motion turns into heat. Matter turns into radiation.
Nothing is ever lost.
Nothing disappears. It just transforms.
So to sum it all up, mass, motion, charge, fields, frequency, they aren't separate things. They're all just different expressions of energy. The universe isn't a collection of static objects. It's an endless dance of energy.
It is. And here's a final thought for you to chew on. If particles are just vibrations in a field, then you aren't really a solid object. You're a process, a continuous evolving pattern of energy interacting with the universe all around you.